So just a question to start off. How many people are familiar with the naturalistic driving study? Okay, about half. So the roadway information database is in conjunction with the naturalistic driving study. So the naturalistic driving study was in 6 states across the United States from 2013 to 2015. Virginia Tech equipped cars and put instrumentation on there to collect a bunch of information from the vehicle that we could use later for safety research and mobility research. In conjunction with that, what we did at Iowa State University was collect the roadway information database. So where these vehicles were driving, what was the actual roadway characteristics during that time period when the drivers were driving on the roadways. Because the TRB and FHWA plan on using this data for hopefully 20 to 30 years, you tend to lose ideas or the information of what the roadway characteristics were there. And we also wanted to collect high information data there at those locations that wasn't readily available with the existing data sources. So through the RID, we've got existing data sources, which we went to all the different DOTs, as well as Esri to get around 200,000 miles of data. The amount of data is very dependent on the state of what they actually collect and what they have available. We also collected some supplemental information. This included any crash data that they had, any safety campaigns that they use, traffic laws that were in place during that time period. And then the mobile van data was the big one that we collected, which we collected around 25,000 directional miles throughout the 6 study sites. And from those, we've also created some reduced data sets that are more easily used by researchers whenever working with the roadway information database. And then, of course, we included the HPMS data as part of the RID. So here's just a few of the statistics from the mobile data collection. Like I said, around 25,000 directional miles. That includes over 500,000 signs on those roadways, around 44,000 curves, 43,000 intersections, and over 7.5 million grade and cross-slope readings across the states. Once we got all of that data, we created a linear referencing system, mainly of the national state primary routes, but within each of the study sites, we got all the local routes as well, because the naturalistic driving study, the drivers were allowed to drive wherever they wanted. They weren't limited to any locations. So that level just has the base level information is what we built our linear referencing system on. And we decided to build a linear referencing system for each of the states so that whenever researchers were using it, they didn't have to learn a new linear referencing system for each of the states, because each state is different in how they use their linear referencing system. With the mobile data collection, these are the main characteristics that we collected. So we got alignment to get where the curves are across the states, barrier, lighting, shoulders, signs, guardrails, intersections, rumble strips, median, and then we also got a front right-of-way video log across the entire network. Here's some examples of the video log and some of the data that's collected. So in the top left corner is a picture from the video log. It just shows just essentially like Google Street View, but kind of like a snapshot in time during the study period for researchers to use. And then this is how we laid the data along the roadway. So of all the different elements that we collected, you've got lanes as one continuous layer throughout it. The lanes or any of the attributes will break at any significant change from one roadway element to the other. But what this gives us the ability to do in GIS and any database is to do dynamic segmentation. So dynamic segmentation allows you to overlay either through an intersect or union of matching similar features on similar segments of roadway. So in this case, if we have an input variable of, say, lanes, and the lanes change from 1 lane to 2 lanes to 3 lanes, and then we had another attribute of, say, guardrails or a barrier here, you could identify quickly what type of lane configuration there was for the barriers. And with all the attributes that we can do multiple of these dynamic segmentations together within GIS. So the options currently existing for using the RID is you can either get the data warehouse from Iowa State University, and you can use ArcGIS. This requires having ArcGIS to be able to use the data warehouses. You do need to have some experience in ArcGIS to be able to process the data. And then dynamic segmentation is more of an advanced functionality that you need to have some familiarity with and understanding really the underlines of the RID to get it to function correctly. We did do some efforts with FHWA last year to create a dynamic segmentation tool that is more for some other users to explore the data, but not have to have as much of that GIS experience. But it still does require that you have ArcGIS because it's using tools within ArcGIS to run the functions, but it makes it a lot easier for basic users. But the kind of limiting factor is having that experience, and all of these tasks still take some time to explore the data. And so what we wanted to create was an exploration tool that just makes it easier for somebody to explore the data, visualize where the locations are, and quickly get immediate results of whether a research question is even feasible based on the data that's available there. So we created this exploration tool, or in the early stages of creating the tool, that's a web-based tool using Tableau that a user can interactively select different roadway features that were collected through the mobile data collection and get feedback of where those locations were started. So it is a web-based tool. It can create these summaries quickly for you, but the cons of it is we're currently only doing mobile data collection, and we can expand to other data sets such as our reduced data sets or HPMS. We're limited on the other data sets that we get from the states because they aren't consistent across the states, so there's a lot of extra effort to do that for each of the states. So once you get to the tool, you get an initial landing page which just shows you the miles that were collected of roadways across, in this case, Florida. It gives you a number in the bottom left corner of just the total number of miles, and then all of your attribute selections over here. So you would first choose which of the 6 study states you wanted to look at, and then you would enter what type of information. So if a user was interested in, I only want to look at a location that has left rumble strips and shoulder widths of so many feet for a specific research question, they could ask that question and get immediate results showing how many miles. So in this case, I just wanted to filter it of how many miles of roadway did we have that were 2 lanes in Florida. And I get a map that shows me where those locations are, as well as the total number of miles, to see if it's even worth my effort to request data from VTTI, because it is an expensive effort to request data from VTTI and time on their hand to get data back to you if it is something that isn't even feasible. After you do make the selections, we do have a summary slide, which kind of gives you a breakdown of the different characteristics on each of those roadways. So once you do go to the summary slide, in the top left corner, you can choose which of the summaries you would like to create. So if you want to get a summary on the rumble strips, you would make that selection, and it would just provide a basic bar chart that just shows you what the breakdown of the rumble strips are in the roadway miles that you selected. So in this case, on the two lane roadway miles, I had around 800 miles of no rumble, and then the other ones were between right edge line and center edge line. And Omar Samadi is the one that's the lead for Iowa State University, as well as Zach and I supporting them. So any questions?
Is this available to everyone to use, or is it just internal?
Right now, we just got our, I guess, continuation of our support contract for the FHWA, so it's kind of, We built it as just kind of an exploratory internal tool for us to use, and as you can see, some of the numbers are a little wonky because we only collected 25,000 miles, and my first slides showed 10,000 just Florida. So we're still working out some of those kinks, but that'd be something we do if FHWA wants to go forward with it.
Yes.
Can you just expand? I'm not entirely clear on the role that Tableau is playing. So you said it's in Tableau
Yep.
for your tool. Are you importing the mapping from somewhere else, or is Tableau doing the mapping and the segmentation?
So Tableau is doing the mapping. We just bring in the begin and end coordinates, so it is all straight lines. We've done all of the processing of the data in ArcGIS already. So basically coming down to the least common denominator of all the different roadway elements of lanes. So you get actually a ton of really, really short segments.
Highly segmented.
Exactly. And so it's more of just a visual showing on Tableau using those coordinates, and since they are short, they will follow the roadway pretty well. But then Tableau is more just the interactive, being able to query it, having the filters there, and then making it a web-based tool.
The